Morning, students. In the previous classroom discussion topic, we had a discussion on different operations on double linked list. Now, in this CDT, we are going to discuss about a new type of list, linked list, which we can call it as XOR list. We are going to discuss that. Now, I would like to share my screen. Hope my screen is visible to you. So, this is the week 9 lecture 3. So, XOR linked list topic for discussion is on XOR linked list. So in the previous classroom discussion topic, the summary of that previous unit is that we discussed about the different operations on double linked list like creation, deletion, and then insertion operations, traversal, searching operation like that we have discussed that. As similar to that here, now we are going to discuss about a new type of list which we can call it as XOR linked list. So the objective of this today's session is that we are going to have a knowledge on the exclusive or linked list operations. The outcome of this today's session is that upon completion of this CDT, students will be able to implement the operations related to this XR linked list. So what is meant by XR linked list? So if you try to understand that the node structure for a double linked list will be like this: the data field we have and link to the previous node and link to the next node. So there are two link fields along with a data field which we want to store in a single node of a double linked list. Suppose if we see that this double linked list, because we are storing two link fields pointing to the previous and next nodes, so a lot of memory is going to be used, not only the data which we are going to store that. So the ordinary double linked list requires the space for two fields to store the addresses of the previous and next nodes. So now there is another different memory efficient version of a double linked list which we can be created using only one space for the address field with every node. Just like a single linked list, only one memory address will be used for storing of this. So this memory efficient double linked list is called it as XOR list or memory efficient list, which uses the bitwise exclusive OR operation to save the space for one address field. So instead of two address fields, as similar to this, what we have taken in our ordinary double link list, in exclusive OR list, we are going to take only one link field we are going to take, and within that one link field, we are going to make use of this bitwise exclusive OR operation to store the link fields. See how we are going to use here. The memory representation of exclusive or linked list, if you take it as in the exclusive or linked list, instead of storing memory addresses, every node store the address of previous and next node. XOR operation of previous and next node exclusive operation value is stored here. Got the point here? So like this here we are going to see. So ordinary representation versus exclusive representation. If you take it as node A, so previous is null, next is address of B. So previous is null and next node address B. So at node B, previous is equal to address of A, next is equal to address of C. So previous is address of A and next is address of C. So node C, so previous is address of B, next is address of D, and at node D, previous is address of C and the next is null, because previous is the address of C and next is null. There is no next node. So like this, we are going to store the exclusive OR operation to store that address value. So call the address variable in XOR representation as NPX. So that is nothing but exclusive OR operation of next and previous link fields. We are doing that. So while traversing XOR linked list, we can traverse the XOR list in both forward and reverse directions. So while traversing the list, we need to remember the address of the previously accessed node in order to calculate the next node address. So node A, NPX is equal to 0 exclusive OR of address B. So bitwise XOR of 0 and address of B. At node B, so NPX is equal to address of A exclusive OR of address of B. Bitwise exclusive OR of address of B, we have to store that. At node C, we are NPX value is computed as address of B exclusive OR address of D. So like this, at every node, if you take the last node, NPX value is address of C exclusive OR 0 bitwise exclusive OR of 0 we are taking that. So what is this reflection spot one? What are the advantages of XOR list over a double linked list? If you see that, okay, so we are trying to save the memory. One link field we are trying to remove by making use of bitwise exclusive OR operation in the XOR list. It is also the memory efficient way of storing the double linked list. Fine. So if you are not able to answer this question, please watch the video from the beginning. So lecture outcomes are revisited here. After completion of the session, students will able to implement various operations on exclusive or list. So the programming part, you can refer this code tantra or lab manual. We have this program on exclusive or linked list. Fine. So the summary of the session is that an ordinary double linked list requires space for two address fields to store the address of previous and next nodes. So whereas this exclusive or list, which are also called it as memory efficient version of double linked list, only requires one space for the address field with every node. So this memory efficient double linked list is called it as exclusive or list, or memory efficient double linked list we can call it as. So the operations on XOR list can be defined it as creation, insertion, deletion, and traversal operations. We can do that. So this is a lecture level practice problem. Write the program to insert a node in XOR linked list. And these are the further readings on this particular topic. Fine. So thank you, one and all.